February 20, 1943, north of Kasserine Pass, Tunisia. No after-action report could ever fully describe what the German tank commanders saw that morning. American Sherman tanks were performing maneuvers that violated every rule of Wehrmacht doctrine-coordinated movements that seemed impossible without visible signals. Through the haze and smoke of the North African battlefield, 5 Sherman tanks, scattered by rough terrain and completely out of sight of one another, advanced on German positions with timing that bordered on supernatural. No signal flags, no flares, no dispatch riders darting between vehicles. Yet each tank moved as though guided by a single mind. They covered one another's blind spots with precision that defied explanation. Each crew seemed to know exactly where their comrades were, as if connected by some invisible thread. Inside their Panzer-Vs, German commanders struggled with their few G5 radios, straining to hear orders through a constant roar of static that overwhelmed their amplitude modulation systems. Their 10-watt transmitters cutting edge in the 1930s barely reached a few hundred meters when the tanks were in motion. Many German tanks had only receivers, incapable of transmitting or calling for help. What the Germans did not yet understand was that the Americans were operating with technology they did not even know existed. Every U.S. tank carried a new kind of radio frequency modulation sets with crystal-controlled precision, 25 watts of transmission power, and clarity that cut through engine noise and battlefield chaos like a blade through smoke. 8,000 miles from Detroit's factories, the most decisive technological advantage of World War II was revealing itself. It wasn't in thicker armor or a larger gun. It was in the invisible electromagnetic waves that linked every American tank crew in a real-time network the Wehrmacht could not imagine. The change had begun on July 22, 1941, when the U.S. Army standardized the Signal Corps radio sets SCR 508, SCR 528, and SCR 538 for all medium tanks. While German armored divisions surged across the Soviet Union, relying on limited radio communication between command tanks, American engineers were developing a breakthrough that would quietly change the future of mechanized warfare. At the Galvin Manufacturing Company, later known as Motorola, a small team of innovators perfected frequency modulation technology that would make all existing German radio systems obsolete. Among them was Daniel E. Noble, who envisioned how FM could be applied to armored vehicles, and Henryk Magnuski, the lead RF engineer who solved the immense challenge of adapting delicate electronics to the brutal environment inside a tank. Their combined efforts produced a radio set weighing about 181 pounds, transforming every Sherman into a node within what could rightly be called the first digital age battlefield network. The transmitter, designated BC-604, delivered 25 watts of output power 2.5 times more than the German FUG-5. Operating between 20.0 and 27.9 MHz, it offered 10 crystal-controlled preset channels, ensuring unmatched frequency stability. Its dual BC-603 receivers allowed tank commanders to monitor 2 channels simultaneously, a feature that would prove vital in combat, as it enabled leaders to maintain contact both with higher command and subordinate units. But the true revolution lay in frequency modulation itself. Developed by Edwin Armstrong and licensed to the U.S. military, FM technology eliminated the static and distortion that crippled amplitude-modulated systems. Every spark plug firing, every engine whine, every burst of artillery that rendered AM radios useless was filtered out by FM's noise resistance. Where German tank crews fought through a storm of static, American crews heard clear, confident voices. When Operation Torch landed U.S. forces in North Africa in November 1942, the 2nd Armored Division rolled ashore near Safi and Fadala with their SCR 508 radios ready for battle. What followed was a communications revolution that stunned German observers. The Afrika Korps, despite being one of the most experienced armored formations in the world, fought under crippling communication constraints. A typical German platoon of 5 tanks might have only 1 or 2 vehicles equipped with a FUG-5 transceiver capable of both sending and receiving messages. The rest carried only a FUG-2 receivers. They could hear orders, but never reply. Command tanks, distinguished by their multiple antennas, became obvious targets. When those vehicles were destroyed, entire platoons were left leaderless and mute. In contrast, every Sherman tank could send, receive, and assume command functions if needed. This redundancy gave American units a resilience that German formations lacked completely. The first large-scale proof of this advantage came during the Battle of Kasserine Pass, February 14–24, 1943. Though the Germans technically won that engagement, they were shaken by what they witnessed. Across nearly 50 miles of chaotic fighting, scattered American elements maintained precise coordination. Tank crews who had never met before managed to execute synchronized maneuvers, share intelligence, and request artillery fire all through crisp, static-free FM communication. German signals intelligence intercepted American radio traffic and was astonished by its clarity. Reports from the 10th Panzer Division noted that U.S. transmissions remained readable at distances where German equipment produced nothing but noise. More alarming still, the Germans discovered that every American tank could transmit not just the commanders. Their own FUG-5 radios, operating on AM frequencies between 27.0 and 33.3 MHz, were simply outclassed. The 10-watt transmitters struggled to maintain contact beyond 2 or 3 kilometers in ideal conditions, and far less when on the move. Every spark, every motor vibration flooded their channels with interference. By contrast, the Americans had mastered the invisible domain of radio frequency, and the battlefield would never be the same. When American armor landed in Italy in September 1943, German commanders assumed that the steep terrain would nullify any radio advantage. But the opposite happened. The mountainous valleys that disrupted German amplitude-modulated radios only highlighted the strength of American frequency modulation. The SCR-508 maintained crystal-clear communication even through rock ridges and deep ravines where German radios fell completely silent. As U.S. forces advanced toward Cassino, tank platoons separated by entire ridgelines executed perfectly timed assaults. American after-action reports described coordination at ranges where German sets could only produce static. The same pattern repeated again and again. Terrain that crippled German communications merely emphasized the adaptability of FM technology. Then came June 6, 1944, D-Day. As the first Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios kept them in contact not only with one another, but also with naval gunfire support. Such cross-domain coordination was far beyond anything German technology could achieve. But the dense hedgerows of Normandy soon revealed a critical flaw in the otherwise seamless American communication network. Tank radios operated on 20.0, 27.9 MHz, while the infantry's portable SCR-300 sets used 40.0, 48.0 MHz, two completely incompatible frequency ranges. On the battlefield, this meant that tank crews often could not hear the warnings of nearby foot soldiers. German infantry, armed with Panzerfausts, exploited this weakness, ambushing tanks that their own comrades could have saved had they been able to communicate. The Americans, however, adapted with characteristic speed. Within weeks, a remarkably simple field innovation appeared. Tank crews mounted EE-8 field telephones inside metal ammunition boxes welded to the outside of their tanks. These talk boxes were wired directly into the internal intercom systems. Infantrymen could pick up the handset and speak to the tank crew instantly. By Operation Cobra in late July 1944, this improvisation had become standard equipment across armored divisions. It revolutionized tank infantry coordination and erased one of the last weaknesses in the American communications network. During Operation Cobra, July 25–30, 1944, the U.S. 2nd Armored Division, under Major General Edward H. Brooks, commanded more than 200 Sherman tanks through radio networks that provided an unprecedented degree of battlefield control. German defenders from the Panzer Lehr Division faced an enemy that seemed to possess almost supernatural awareness. American tanks reacted instantly to threats reported by other units miles away. Artillery fire, coordinated through tank radios, could strike new targets within minutes. The contrast with German forces could not have been sharper. Panzer Lehr, once the pride of Germany's armored corps, was fighting in what could only be called communication poverty. Many of its tanks had no functioning radios at all, and depended on visual signals in hedgerow country where visibility rarely exceeded 100 meters. Those few with working radios suffered constant interference and short range, which made coordination nearly impossible. The irony was bitter. Germany had invented the idea of radio-coordinated armored warfare. Heinz Guderian, the father of Blitzkrieg, had championed radio-equipped tanks since the 1920s. His 1937 book, Achtung, Panzer, emphasized that communication was the lifeblood of mobile warfare. Guderian's doctrines had enabled the lightning victories of 1939 and 1940. Yet by 1943, German industry could no longer supply enough radios to meet his own standards. Production figures told the grim story. In 1943, Germany built roughly 5,700 medium tanks, but fewer than 2,000 FUG series transceivers. Most went to command vehicles and assault guns, leaving regular tank platoons mute on the battlefield. Soviet forces fared even worse. The famous T-34, though the most numerous Allied tank, often went into battle without any radio at all. Soviet units relied on colored flags or prearranged signals tactics that proved disastrous against German forces in 1941. Lend-Lease aid later provided some relief. American SCR-508 sets equipped Soviet command tanks, but even by 1945, only about 1/4 of Soviet armor carried radios. The contrast with American capability was striking. While the Red Army struggled to equip 1 tank in 4, the United States achieved 100% radio deployment, and not just any radios, but sophisticated FM systems designed for clarity and reliability. Motorola's factory in Chicago became a symbol of American industrial transformation. Before the war, the company produced car radios. During wartime, it retooled entirely to mass-produce advanced military sets. Each SCR-508 contained 2,748 precision components, including 474 capacitors and 385 resistors. Its crystal oscillators had to maintain stability under extremes of temperature, shock, and vibration. Production ramped up with staggering speed. 1942, 3,800 units. 1943, 11,400 units. 1944, 24,000 units. By the end of the war, over 50,000 radio sets had been built enough to equip all 49,324 Sherman tanks ever produced. No other nation even approached such a feat. The SCR-508 offered far more than just static-free communication. Its crystal-controlled stability allowed tank crews to preset frequencies before battle, ensuring that channels remained synchronized even in the chaos of combat. By contrast, German FUG-5 radios, tuned by variable capacitors, were prone to drift off frequency as tanks rumbled across uneven ground. The American system also featured dual receivers, letting commanders listen simultaneously to both company and platoon networks. Orders could flow instantly down the chain of command, while leaders maintained real-time awareness of their subordinates' positions and situations. Internally, the BC-606 intercom linked every crew member to the commander. Throat microphones and noise-canceling headsets allowed tankers to speak clearly over the roar of engines and gunfire. Many German crews, lacking intercoms entirely, were forced to shout or use hand signals. Primitive methods that wasted precious seconds in combat. Power management was another hidden advantage. The SCR-508 operated on either 12 or 24 volts, automatically adjusting to available current. Its dynamotor power supply delivered filtered, stable energy that suppressed electrical interference. German radios, powered directly from vehicle circuits, suffered from constant static generated by spark plugs and electric motors. These engineering refinements had profound tactical effects. The universal installation of high-quality radios made the combat command structure, the flexible, task-organized backbone of U.S. armored forces possible. American commanders could create ad hoc battle groups from different battalions, confident that every vehicle could communicate seamlessly with the others. German units, bound by rigid hierarchies and limited radio distribution, had no equivalent flexibility. This difference became starkly visible during the Battle of Ericourt in September 1944. The U.S. 4th Armored Division faced multiple German panzer brigades equipped with the formidable Panther tank superior in armor and firepower, Yet it was the Americans who prevailed. Through the SCR 508 network, every Sherman could instantly report enemy movements. Tank destroyers received firing data from tanks they couldn't even see. Artillery observers in command Shermans relayed coordinates to gun batteries within minutes. In 3 weeks of fighting, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 kill ratio that defied the expectations of those who measured strength only in armor thickness or gun caliber. German intelligence never fully understood why their opponents seemed to move with such uncanny coordination. Field reports mentioned excellent American radio discipline, but analysts attributed it to training rather than technology. A captured report from September 1944 concluded, American tank units display good communication discipline and coordination. This appears to result from extensive training and strict procedures. The assessment missed the point entirely. The Wehrmacht simply did not grasp that every Sherman tank possessed a powerful FM transceiver, making it as capable of directing battle as any command vehicle. As a result, German forces continued to target tanks with multiple antennas, assuming they were command vehicles, never realizing that every Sherman could serve as one. They planned ambushes expecting U.S. units to fall apart once visual contact was lost. Instead, the Americans maintained cohesion through invisible radio links, executing maneuvers that German doctrine said were impossible without line-of-sight signals. By March 1945, as Allied forces closed in on the Rhine, this communication superiority reached its peak. The dramatic capture of the Ludendorff Bridge at Remagen demonstrated how swiftly American command networks could react. When the 9th Armored Division discovered the bridge intact, radio messages reached 1st Army headquarters within minutes. Within the hour, entire divisions were being redirected to exploit the opportunity. German formations, still dependent on landline telephones that Allied aircraft routinely severed, could not respond in time. American tanks, connected through FM networks, established a secure bridgehead defense in record time. Platoons from different battalions coordinated as a single entity, calling artillery and air support through shared radio nets. German counterattacks launched piecemeal due to poor coordination were annihilated in detail. In April 1945, during the encirclement of the Ruhr Pocket, the full power of American communications came into view. Armored columns from the 1st and 9th Armies executed a complex double envelopment entirely by radio coordination. Inside the pocket, 325,000 German troops found themselves trapped, largely because their own communication system had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German signal centers. Cut off from higher headquarters and neighboring units, German formations disintegrated. Field Marshal Walter Model's final transmissions before total communications failure captured the desperation of the moment. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The American FM radio network did more than change tactics. It changed the psychology of combat itself. Tank crews who could speak instantly to one another, to infantry, to artillery, and even to aircraft experienced a profound shift in confidence. They no longer felt isolated inside steel boxes, but connected to an army that could see, hear, and react as a single organism. German soldiers, by contrast, often fought in silence. Reports from captured crews frequently mentioned the unnerving calm of American coordination. Their tanks move like a school of fish, one panzer commander observed. If you strike one, the others immediately respond, before you can reload. That sense of cohesion came not from greater bravery or superior training, but from the invisible lattice of radio communication binding every vehicle, every platoon, every division into one living network. It was this invisible weapon, rather than any specific tank model, that gave the U.S. Army its decisive edge. The M4 Sherman may have been outgunned and outarmored by the Panther or Tiger, but the Shermans fought as part of a synchronized system, while German tanks fought as individuals. War is not merely the sum of machines. It is the sum of their connections. After 1945, The U.S. Army absorbed this lesson deeply. The doctrine of command and control through communications became a central tenet of post-war military theory. The newly formed Bundeswehr in West Germany adopted FM radios modeled on American designs, and NATO standards were built upon the SCR 508's architecture. Motorola, the company that had once produced car radios for the civilian market, emerged from the war as a technological powerhouse. Its engineers, drawing on battlefield experience, developed the handy-talkie and later the first transistorized radios, setting the foundation for modern mobile communication. The principles perfected in 1943, the use of FM for clarity, channel separation through crystals, and reliable communication under extreme conditions, became the DNA of the communications revolution. In the decades that followed, the same philosophy reappeared in new forms. During Desert Storm in 1991, American tank units, now connected by digital networks, repeated the same feat as their predecessors at Kasserine and Aracourt, defeating a numerically equal enemy through information dominance. The technology had changed, but the principle had not. Victory belonged to those who could coordinate faster and clearer. Military historians often search for decisive weapons: the best tank, the most powerful gun, the most innovative aircraft. Yet the real revolution of World War II was not made of steel or explosives. It traveled on electromagnetic waves, invisible but unstoppable. When General Dwight D. Eisenhower later reflected on the war's outcome, he credited not just the courage of soldiers or the strength of industry, but the ability to communicate. Without the means to coordinate, courage and power are wasted. Our radios gave us the power to act as one army, no matter where each man stood. Today's digital battlefield, filled with satellites, encrypted data links, and real-time coordination, can trace its lineage directly back to the SCR 508 inside a Sherman tank rolling across Tunisia in 1943. The transformation that began with 5 tanks moving in perfect unison under a haze of desert dust had redefined warfare forever. It was the moment when victory moved from the strength of armor to the strength of connection,